And see, yeah. Maybe I should just tell you that in terms of this cleaning here on the editor, and I'm not asking you to do cleaning here at all, but it applies and it works the same way that you've seen before in the model. And I'm finished. I close and I say yes to save the changes, and that is saving back to this one here. The minute I press save, then I'm saving back to the database itself. It's just a two-step thing here. Now let's load the sound velocity data using the ASCII importer. Add navigated data, patch test ultrasonic, and then it's this one up here. Sound velocity data. And of course, data type is SVP. See, we actually already created one, but that doesn't work on this data here. So we have to create a new template. Or was it this one there we create? I can't remember. New template. Nah, as a matter of fact, that's not true, because we can use this one here. Atlas with header, that's a predefined one that's already there. You have it, and I have it. Atlas with header. No reason to make a template for this. So next. This is again something that is irrelevant for us. Patch test, create folder, SVP, and OK. And it's and just have a look at it in the data editor. This one, like this. You can see that it's well, not very dramatic. Hardly anything is happening. Also notice how this is a little bit awkward. Normally we're seeing sound velocity profiles with the water column in the y-axis and sound velocity in the x-axis. Here, it's the other way around. Now, next thing would be to import the title data. Again, ASCII file importer. Add this one here, title file. These are actually predicted tides that I created using total tide from the British Admiralties. Quite useful, actually. Next. Tide. You guys don't have a template that works, so we're going to create a new one. And this is very similar to what we did yesterday with the pressure, more or less the same, as a matter of fact. Space, tab. Not enough. We need to have the date and time subdivided into day, month, year, hour, minute, second. So we need to have the slash and the colon. This is also what we did yesterday. The difference is that this is not pressure, this is tide. Column index 6. Next, so everything is of primitive type integer except column index 6, which is double. So let's do it one by one. And double. Display is formatted. And it looks as expected at this stage. The next step would be to define the data translation. We have two output fields, time date and tide. Starting with the time date, we change the encoding to date here. Year, month, day, hour, minute, second. And now input columns, all 6 must be defined. Year is index 2, month index 1, and day is index 0. Hour is index 3, minute index 4, and second is then index 5. So from left to right, 2, 1, 0, 3, 4, 5. This was also what we did yesterday for the surface pressure. Now we'll jump to the next output, that is the tide output. Select it from up here. Tide. Encoding is double. Data column is index 6. That's this one here. Next, no conversion. Finish. And I'm not sure that I have this already. Like this. This is the one I just created. And remember, just to be on the safe side, to choose one of the others and then choose the one that you have created back again so that it takes effect. Next, 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 finish, patch test, tides. Like this. So basically, you guys are going, this is your exercise, but the exercise is really related to to the patch testing model more than anything. So I'm just going to, so that we're actually sure that you have the data loaded correctly. We'll just do that anyway, like this. I'll go to the data editor and load the title file and see how it looks. You can see that it's actually 1 meter title difference or variation. This is in the English channel, so that's there's quite a lot of tide there. From 8:30 in the morning, AM, to 11:08 AM as well. If we look at the time of the data, we can see that the all 4 blocks are covered by the title file. That is a must, that it's covered. Otherwise, of course, you cannot correct for it. Let's load the data into the head editor. You can see here that on the original data, there was a side scan snippet, and that is actually not the case here. In the old Naviscan, the old Naviscan was able to create 2 different SPD files, one with side scan and one without side scan. Header of those 2 files are the same. However, the one that is called X underscore and then the name does not contain side scan data. So that we cannot do that anymore. That caused some problems. But as you can see here, it says that side scan should be available, but it really isn't. Yeah, apart from that, some velocity profile, add profile here, some velocity, selection policy by time. I don't get a warning. A window, no filtering there, options, apply merge and convergence, surface-based, use heave, and use induced heave, that is remote heave, as you also sometimes call it, and we're not going to use Bethy. There is no Bethy in the data anyway. Geodesy, standard geodesy, no datum shift, and we'll use the geodesy online. Tide here. We could choose a folder because there's only one tide block in the folder, but you can also just take it from down here. Tides like this. And then use nearest profile. We don't have more than one profile. I should mention down here this possibility if you're using predicted tides. We're using predicted tides, and the idea down here behind this option, use air pressure correction, is that it is assumed that the tide will vary with surface pressure. Higher pressure, the lower tide. But be careful with this, only use it if you're absolutely right that your water and your tides can flow freely. So that, of course, is something you should be really careful with. Which reminds me, we should, of course, remove this pressure block. Like this. But we haven't enabled it here, so. But anyway, ultrasonic old format, same as before, quality threshold of 13. Properties not relevant notes, not relevant report. Yes, it's being visualized. So I would say okay to all of this. And yes, I want to apply these changes. And I did not get a warning saying that one or more of the blocks is or are not fully covered by the title data, because they're all fully covered. You know, when you're doing a patch test calibration, there's always someone telling you, are you finished soon? Do you have some results? And that's basically what this is all about. As soon as possible and as fast as possible, we want to get results. So I would, of course, I would apply all these things that we have applied. I would also go in and check the data, but I would do it very fast. Go into the data editor, everything, and then simply check, just a rough check. And you can see that the heave, for instance, is centered around 0, which is really great. Track also looks nice. This is C now, as I said. And then simply toggle to these 4 blocks and say, this is fine. I didn't see any outliers or any spikes or anything like that. Not in there. I'm really concerned about the heave, because if the heave is not, or the motion sensor is not aided, then when you make fast turns, then it takes a little while sometimes before the heave settles. But this one was aided, so heave is fine all the time. No spikes here. I cannot check the multi-beam anyway, so I will basically say, okay, close the window here, and then I'm happy. Yeah, I can see the multi-beam has been edited, but that was editing down here. That's it in NaviEdit. So if I want to access the data in NaviEdit, or in NaviModel, sorry, then, well, you would probably say that goes without saying, but NaviEdit doesn't have to be opened, or the job planner doesn't have to be opened for NaviModel to access. The whole idea is that NaviModel is really accessing the database, and it can do that as long as the server is running, then you'll be fine. I got the data here. I can create a DTM and clean it. And that's it. That is one of the things that you are going to do, you're expected to do. Once you have cleaned it, you must write back to the DTM. Once you have done that, remove the DTM that you're using for the cleaning. I said write back to NaviEdit, of course. That's what I meant. Once you've done that, you can create a patch test with all 4 blocks. And then you have this this dialog here, whereby you can define, for instance, which blocks to use for the time calibration. And that's actually these 2. I can just show it to you like this. You can see then they recognize the colors should be like this. And then I only have 1 monitor. You have, or at least some of you have more than 1 monitor. Can move this one around. So basically, define the blocks and define the area. And then find the area, something like this. It should be somewhere in the middle, and then end by double clicking. Now, for the actual pass test calibration, it is essential, because we want to use automatic results, it is essential that you check the long profile. You can see I just moved the long profile so that it actually matches my area here. You can also move the profile sideways. That is done by this slider here. See, now it disappears. Now it comes back. You also have to set it up. Calculation setup. Calculation method, always standard deviation. It is described in the e-learning. It's also described in the PowerPoint presentation that I will attach to the exercise notes that I'll send you in the afternoon. We are calculating all results. We might as well. Tile corrections, true. Sound velocity corrections, true. We don't have any Bethy, so that is set to false. Draw percentage in 3D view. That's what we have here, and you can limit that to a lower percentage if you have problems with your graphics card. Stepping type symmetrical. That is basically all the time trying to find the best possible result by taking the previous result and then taking some symmetrical and smaller steps on either side when you are calculating the optimum standard deviation. The optimum standard deviation will be related to the optimum time result in this case. And then we have some search windows, time search interval, and number of steps. 11 here and 18 here. Just use the default values. That's the best thing apart from these two up here, or actually this one here and the Bethy correction. Now, once you've done this, you press the outer button and then you see what happens. You can see that Navimod is varying the results and it's constantly showing you the consequence of the results down here. This is the current value. This is the best fit time value, and this is basically the time offset of the navigation relative to the time of the Motion Echo Sounder. This is 0.05 seconds. That is 54 milliseconds. And this is not zero. So I have to explain this because people are always taking this the wrong way. Time is always zero. Because if time is not zero, then you have not set up your system, your synchronization correctly in Navipack Naviscan and in the Motion Echo Sounder. So why am I getting a result like this? Well, try to imagine that what we're actually using to determine the time here is points on the seabed, 16 meters down. We're using acoustics to determine that. And at the surface, we have a GPS instrument with a certain accuracy. So all of this is included in this time determination. It's also included in the pitch and the roll and the heading determination. But in time, in particular, you can see it. Let's say that we have an accuracy of the sea now in the range of 0.2 meters. And we're always comparing two lines. Let me try to show you what I'm referring to in a little while. In the data I have given you, here there's something called patch test lines, and then you can see it gives you some information about what lines to use for what. But you can also see the speed. So we have time, we're using line 0 and line 2. The difference in speed is 2 knots, which is 1 meter per second. Now, 1 meter per second, 0.054 seconds is actually 5 centimeters with this time difference. So 5 centimeters, and our standard deviation of the navigation is 20 centimeters. You can imagine that this value here can be explained by the standard deviation of the navigation. The same applies. We saw yesterday or the day before yesterday when we did USBL calibration, we had a certain accuracy, or you could say inaccuracy of the USBL system that explained the offsets that we had there. Still set it to 0. So basically, same applies here. The time, as long as it has a reasonable value, we will set it to 0. If we cannot explain it, if it's half a second or something like that, then we need to assess our configuration. That is, we have to go and check, is there something wrong with the synchronization? But this is fine, as you can imagine, and I'm sure you cannot, I don't always get these kind of results because it also depends on the area that you're choosing. But always when you continue, set this one to 0. This is essential that you set it to 0, and then you can continue with the others. Right. This is the first iteration, and the second iteration is simply where you go here and choose to auto-calibrate. That is auto iteration of everything. You can see it doesn't include time because we don't want to use the time results. We want to use the manual result here of 0. But the others, we are doing iterations where we are using the previous results and constantly refining our results. This is essential to do that. I think I have suggested 3 iterations. Makes perfect sense to do that. The first iteration is when you manually define the area and the blocks to use. Iterations here, number of iterations. Right. Create report and send it to me once you're finished and you're happy with what you have done. It's described in the exercise notes, so don't worry about it. The data that you're using here are the same data that was used in the e-learning module. And I'm not saying that you will arrive at the same results, but something like that. There's also that I will send to you. 2 seconds. On the documentation side, there is a document on the level model. It's called level model patch testing. And I'll also send that to you. But of course, the key to everything we're doing is this slide here saying that what is the purpose of the calibration? The purpose is to determine the mount angles of the multi-unit transducer relative to the 3 axes of the local coordinate system of the vessel / ROV. We call these figures the roll pitch and heading mount angles. Yes, to determine, telling us that this will give us numbers. A secondary purpose to confirm the relationship between time tagging on the multi-beam and the time tagging on the position data. We call this the latency or the time value. But this is a confirmation. So either yes or no. No numbers here. Not allowed to have numbers. I mean, you're allowed to do whatever you want to do, but this would not be correct from a survey point of view to come up with a latency. Yeah, that's basically it. You are now ready to do a patch test calibration, but before we do that, I want to open the hydrographic project. I don't want to save this project. This is the hydrographic project that we were working with the other day. Not so much to say about it. We have a terrain model that has been interpolated with the radius of 7 cells. And of course, we have cleaned the data. You can see there's a navigation channel here. It's actually, I can tell you that there's been a jack-up rig standing here many years ago in 1990. I know that because I was working for a company. We were, if you look at the pink satellite, you can see this bridge here. This is the low bridge and a suspension bridge. And here's a tunnel. Tunnel is for the trains. And the suspension bridge is for normal traffic. And over here, combined train and normal traffic. So I was working for a company that was producing or making this bridge, and the low bridge was constructed based on prefabricated elements that were created here in this area. There was a factory here. This is actually was where these elements were shipped out. There was a pontoon crane that was coming in here and then picking up the elements up to 10,000 tons they weighed, and then sailing out through here with the navigation channel all the way out, and then placing the elements out here. At the same time, there was a ferry route that started from here, and these guys were not happy about the bridge, of course, because that meant that they were going to lose their job. Obviously, there's also another ferry over here. This was the ferry for the trains and also other traffic. This was primarily for cars. So there was a couple of incidents where we were actually there was two people were killed because the ferry ran into the jack-up rig or the pontoon crane here. That was very unfortunate. At some stage, we couldn't lift these elements, so they were actually moved out here, and then the They were cast. The final casting was taking place out here, and then the pontoon crane could lift them from this location because of the buoyancy that was there, because it was already in the water. But that's history. That's where you can see these scour marks here, and they're caused by this. And out here, this look like pock marks. They are from the jack-up rig that was used to produce the seabed foundations. There were seabed foundations for each pier here, and then we came with predefined elements or precast elements and put them on top of this. But for whatever reason, I put it here, and it was actually stuck there. They couldn't get it up. They couldn't lift the legs again. It was stuck for 2 weeks or something like that. I had to bring in a dredger to, you might probably see it here. They've dredged some material away from the location of the legs there. But anyway, what we're going to do, we're going to produce some charts in Naviplot, or some plots. So let's try to open Naviplot again. Like this. I'll just move it to the other side here temporarily. Three iterations. Coram. Navi. Let me see what to actually use here. No, I'm not going to use this one. I'm going to use the Naviplot project that you find under Navigated Data, Newport Data, Naviplot. See, Naviplot has a functionality whereby you can export data to a zip file. I'll show you how it works, but basically you can see that there is a project file here in the zip file, and then there is some files here as well. That's a little bit, this is not the way we're doing now. This is old, I think. Yeah, offline training. Oh, a little bit difficult to see. Yeah. We need to find it. But anyway, what I would like us to do is to just extract this one here. And then just extract it to our project. Naviplot like this. So the project folder, Naviplot folder like this. I'll say okay to that. And then we can have a look at it. Naviplot. So here it is. And of course, I can take this NPL file, Naviplot project file, also an XML file, and drag and drop it here and see how it works. I drag and drop it to the project. You cannot see that, but it's, maybe you can see it on your own. It's loading these files. And we're not going to use this project file, but we're going to be inspired by it. It take a little while. This is a display line file. We can also show in the health as display. There you go. This is the project that we created during the training there that I did 10 years ago. Now, all we can see here is that we have a project file. We have something that's called top frame. That's the frame that Naviplot is born with. Underneath the top frame, there are, in this case, two main frames. The bathymetry frame, as you can see, if I select it, you can see the red handles here. And a legend frame, which is this part here. In the bathymetry frame, as you can see, there are quite a lot of items here. One of them is very important. We're going to use that as well. That's the chart definition file. But apart from that, I don't think we are going to use any of it. Like this. Yeah. So basically what I suggest is that we remove everything from here one by one. And this is not sophisticated like Navi Model. You cannot right click and choose delete. You just select an item, press delete, like this. Select an item there, press delete, select an item again, contours. Plot. Don't be afraid, just remove everything because we'll create it in Navi Model and you can see how it works. But the point of all of this, of course, is that I don't think it makes sense to have to start with all these items here and having to create a new chart from scratch, because that takes quite a long time. And you're not here to learn how Naviplot works. I will save my project now. File, save as, and then on a Naviplot, I will call this one virtual on off. Like this. Virtual on off, save. We might also remove some of the items in the legend. That's primarily the key plan information. Key plan is this one here. I can right click and zoom to. You see the key plan. And then I will remove the bitmap. And I'll also remove the chart definition. Yeah, well, basically everything. I'll also do that. And now I can save the project again. Right. Zoom all. So now we have this project here with a legend that is almost completed. Can zoom to chart title, then you can see bathymetric survey of Newcastle Harbour. And if you look at, this is actually a frame. We can see that on the red handles, but it has become a text frame because we have added text to the frame. The text you can see down here on the text. And then if you press the browse button, then you can actually modify very easily. Now it looks like this. You can change the font should you wish to do that. Arial narrow. That's really weird. Nothing happened. Okay. So apparently there are some that. Oh. It looks as if some are not supported. Probably all the Microsoft ones are supported. No? That was really weird. No, doesn't want to. I have to zoom in and out. Yeah, back to where we were before. Right. Newcastle Harbour, and the same applies for everything else. You can also click here and then see browse again and then see what was entered here. And you can write a long story about this. TSS Orion. It's been many years since I've used that system. RTK Heights. Artosonic. And everything. RTCM corrections with a dedicated reference station. So basically, all depths are reduced to DVR 90. That's basically, you saw that we were recalculating the Bethy. What did we recalculate the Bethy? I can't even remember. I don't think we did. Anyone can remember that? We've done so many. Yeah, we did that. If you're in doubt, you can always go in and check your report. Recalc Bethy by GPS height. Using this geoid here, which is basically the geoid that represents the what was that? Where did I see that? DVR 90. This terrain model here. DVR 90. The funny thing is that there's actually a new version of the DVR 90, and that's the one that we're using. So we've actually updated this data. Okay, let's go back to Navi model. One of the things that I would like to do is to create some contours. It can take quite a long time to create contours. So we will make a test area, and this can be done in different ways. You can zoom in and then create a chart like this, new chart. Just call this one 0, or you can call it test area here, like this. Of course, you can move it a little bit. So I'd like to see what it looks like here in this area. That's a little bit, things are happening here. Now in this area, we can choose right click, boundary, create contours. And I'm a little bit in doubt about the contour interval. I don't distinguish between, I have to say, I don't distinguish between majors and minors here. So I always have the same number. You can smooth contours and you can remove small contour curves. We're not going to do that. Cell size factor is 1. Basically means that the cell size of 10 centimeter that was suggested by Navi model is used to create the contours. Navi model can create contours that are based on a cell size that differs from the actual cell size of the terrain model. It can be smaller and it can be larger. Let's try to create these contours and see what happens. And now it comes up with it again. So crazy. 25. I think this is actually the cell size of the terrain model. So let's just take that. There you go. We've got contours. If I exaggerate, vertical exaggeration, again, let's have a look and see the target. Then you can see that in Navi model, the contours are really drawn in not just the horizontal location, but also the vertical location that they're representing. And if you really want to see the contours, then you right-click on the terrain model and choose opacity. And then you can do like this. You can also see that this was apparently the limitation. I didn't choose to do contours any further than this. And of course, contours are created in with a 2D approach relative to this chart that we have here. Down here, this is a flat area. And you can actually see that maybe we don't want to see all these outliers here because that's what they are, going a little bit up and down. So you find the contours on the toppings here. You can also see, and please don't explode any of these because they are huge. There will be an entry for each of these here, even the smallest of contours will be visualized as a single entry. So I want to start by right-clicking and modifying. You can smooth your contours, and I do this for testing purposes. And this is, of course, very important. Contours cannot be smooth in the z-axis direction, because if you do, then they are not in the right vertical location. They have to be smoothed only in XY, in the XY axis, or the horizontal plane. The approach smoothing in every model is special. We use it in many contexts, not just for contours, but also for digitized lines, etc. Basically, we can do several iterations, and we talk about hundreds of iterations. One iteration is basically the running average of the previous and the next point. So it's looking at the previous and the next point, and then using this running average of those two as the current point's value. So let's see what happens. If I smooth once, something happened. I can smooth again. I can smooth as many times as I want, because I can always go back. See, this is now 1,000 iterations. This one we haven't, 2,000 actually. See, I can go back and choose any of them. I can even see the original data. $200. And then perhaps also go up here to see the consequence. I can still change the opacity. Yeah, something like this, perhaps. So basically, this value depends heavily on the data that you have. I've done pipeline inspection surveys where I've used a smoothing factor of 500 or something like that. Here I would, I don't know, something like 100 or 50 or any value in between. I could even choose 75, so that's a compromise. 75. So when I now close this dialog, then Navi model will keep the value, and you cannot change it afterwards. So 75, and I'll even make a note of it. Down here I have some small points. So I want to remove small points, remove small curves, and it's something like 5 meters is probably fine to remove those. There's one here and some others down here, and they're gone now. This is the total length, and if now it's time, you can explode this one here. You can move to these one by one, and you can see the length of it. Try to have this one here. That's just a small one. actually quite large, the majority of these, except for there's one here. That's this one here. But we're not going to use this here. This was just testing, for testing purposes. Let's zoom all the way out. I think I want to remove this these contours here because I don't want to use them. But I remember the settings. And now I will create a new chart. Call it all or entire area, whatever. Cell size 1 meter or 2 meters. For now, that doesn't really matter. What I want to now is to right click on the chart that's called all and choose boundary export. This is a boundary export. There are other exports as well, but this one here, boundary export, that's the one we want to use. Again, it wants to create this export directory. That's fine. Now we have an area exporter looking very similar to the volume report dialog. And you can see there are different items that we can export. We could do it in one go, but let's take them one by one, at least the ones we want. To export, I want to export the contours. Contours 25. Let me just try again. Right click, boundary export. Contours. And then target folder is the export folder of the project, as you can see, the one that was just created. This is just a name. Now I go to contours and then it says cell size factor. And I want to change this to 0.5. 0.5. Smooth 75 and remove small 5. See how it works. Okay. And it's, whoa, already done. Navi model. Holographic. Project export. What? What went wrong?
I think your export was in volumes.nmp instead of hydrographic.
Yeah.
In the target folder.
Yeah, you're right. This is really a new bug in the software because it used to be correct, but I saw it in volumes as well. You create an offset or a folder, but it doesn't output to that folder. Thanks a lot for that. Hydrographic export. Yeah. Oh, it's there. It's a DXF file, but this is the one we're using, and these are just some metadata. And let's try, we can have a check and see how it looks in Navi Model, because we can also show it in Navi Model. Of course, this is how it looks here. Or contours. Yeah, something like this. I see this one. Yeah. Color coding would make a lot more sense if we had more or less the same here from 2 meters. And then color coding here, or the color modes, depth from 2 meters with a step size to anything here. Because then now the colors match, or at least they should. Yeah, see, this is one of the disadvantages of smoothing. Perhaps too much. I'm not sure that I've smoothed too much. I certainly have smoothed, that's for sure. You can see that on the colors. Color mode depth, fade. Yeah. Could try to create contours that are not smoothed and see if they are matching better. That's relatively easy to do. Boundary export. And then contours, no smoothing. Like this. And now you have this shortcut again, right click and here, right click, export folder. No smoothing. Let me try to drag and drop that. Yeah. Let me try to change the yeah, they're certainly matching better. That's quite clear to see here. Anyway, I'm going to use the smoothed in NaviPlot. Let's go to NaviPlot and then zoom to the bathymetry frame. If I right click in on it, I can add the XY data contours. And then Navi model. This one here, all contours. And this is just parts of the area. I want to zoom all. Now fit all, because then it changes the scale. So now basically I have all my contours here in a north-south orientation. Contours are shown. We can change the properties later on, but right now that's not necessary for the time being. I save the project. It's always a good idea. I'm afraid, guys, it's not always as stable as you could wish. Let's go back to Navi plot. And this time I want to create a geotiff in lines with what we saw before. So I don't want to see my charts. Because it's basically going to create whatever I see here. So based on the all, I'm going to make an area export. But before I do that, I want to remove target information. I want to remove the north arrow, and I want to remove the palette and the legend. So I don't have anything in here other than what I really need. I also want to change the opacity back to what it was before. I want to change the color mode depth to a step size of 1 meter, because otherwise I can't see everything. Like this. I don't know. No, I think that's fine. 2 meters. And a step size of one. No. 2 and 1. Like this. This is just so that I can see what's going on. But basically, I will right click on all again. I have a cell size of 2 meters. I will choose a boundary export again. And this time I will make a geotiff. And in the geotiff, I want to use the rainbow palette from 2 meters with a step size of 1. Background color is white, and the light settings are also fine. No fading of colors, no auto range, because I want to use these values that I have defined. Let's see what happens. Okay. Again, here is my geotiff. Not very big. as you can see. Question is if it's a little bit too coarse. So I can change it by changing the cell size here to 1 meter and then repeating the boundary export. Same settings as before. And now 4 times as big. And now it looks a lot better. I could have made a little bit smaller, but I think this is fine for now. In NaviPlot, I can right click and choose add XY data, bitmap, and it remembers the same location that we were using before, like this. So now I can't see the contours anymore. The reason is that the draw sequence goes from up to down, so it's drawing the contours before it draws the bitmap. So I will move the bitmap up and then click here, and now we have the contours in the bitmap at the same time. Let's have a look at the size of the frame, because we're going to use the size of the frame to determine the scales that we are going to use here. Right now you can see, if I zoom this window here, you can see the scale. That's a really strange scale. That's just because we said fit all. So it simply regarded every consideration regarding scale and just put it there. Now, the frame has a size. And of course, this is the physical size of the frame. I don't even have something to write with here on my 2 seconds. I need to get something to write with. Just make a note of this. I know I could have done that in many different ways, but 1.22. So this is A0 multiplied by 0.7. Okay, this is something we need to use. Let's have a look into Navi. Just save this. Let's have a look into Navi model. And then I will go to the project that we unzipped a little while ago. That is the Navi model project that we unzipped like this. Navi plot. See if I can find it. Oops. I have a project. Must be this one. That was not the one I was looking for. plot. This is the one. It's CDF, chart definition file. We can try to open it. Just a simple ASCII file. Open it with Notepad, and then you can see here that we have, well, basically 8 charts have been defined. First coordinate here, these things are northing, they are the center of the chart. This is the rotation or the orientation. And this is the physical width of the chart and the height. And if you remember, we had in Naviplot 1.22 meters multiplied by 0.7. And that is basically a scale of 1 to 500. So it is that simple. But it's something that you have to, of course, take into account. Let's close this one here. That's not what I should have done. I should have closed the other window. Open file location. There it was. You can drag and drop it to the window here. There you go. Now we have a chart definition file loaded. You can see it here. These are the charts. 8 charts here. You can right click and remove it. Chart number 8, because I think that's the one down here, I hope. No, it wasn't. Christ. Which one is it then? It's chart number 1. Okay. Take this one again. I'll remove this one. And drag and drop it again, like this. Now we can remove chart number 1. And now it's gone. So basically, we're using this information in Naviplot for the chart layout manager. Let me show you how it works then. In Naviplot, that is. I can actually do exactly the same thing that I did. I can drag and drop the chart definition file to my chart here, and there you go. It looks like this. And here I can also remove chart number 1. No, I can't even do that. Maybe I can do it by pressing delete. Yeah, so that's gone now. I can now right click on chart number 2 and choose go to view. So 2 things are happening. First of all, as you can see, I'm looking at this part of the chart. Second part is that this layout manager is enabled, so I can toggle between the different charts. If I zoom in and move a little bit, you can see over here that the scale is actually 1 to 500. That's good. So let's try to unselect current chart and go back to Navi model, because I'd like us to be a little bit more sophisticated than just doing something like this. What I would like to do is to create a new chart here. Let me see if I can do that. New chart. Call this one 1. And then this chart is actually showing the entire outline of the area, which is what I wanted. We've got a size down here with 2441, but if we then say 2440 and then zoom in and then say 1400, then we're actually getting, so I multiply my my physical size on the plot by 2000, so I can actually then let that be part of what we are creating. And then I can move it. Something like this. And also see a little bit of the harbor area, but that can also be included in it. I could create 2 new charts. I call this one 9. And this one would be 10 then. And these will then have a size that is equivalent to 1 to 1000. Let's see if I can find it. Here it is. It's this one here. I don't know if it, yeah, I can make it. And then the last one, again, the same. One, 220 and 700. And edit. Like this. Fantastic. A little bit confusing, perhaps, at the moment. Yeah. I can, once I've done this, I can actually open in text editor like this. And then I can choose these. Whoops. That's not so good. Oh, there we go. You have to save it first. So I want to change these numbers here. Eight, 9, 10, like this. Perhaps the sequence should be different. No. Eight and 10. And then I can save as, and I want to save it in, I think it's true enough. It's correct to save it in Navi model. Hydrographic project toppings, and just call it virtual. on-off.cdf. Save. I want to remove it from here. And then take it from the toppings folder and drag and drop it again. Because as you saw, it wasn't updated. Didn't I save it? Christ. It's almost unforgivable. Oh, there it is. Ooh. Drag and drop it. As you can see, now it's there and in compliance with. So even though I open it in text editor, it will not be updated in the model. So I have to save it to another location and then drag and drop it in here. But the point is that I'm now ready to take this into Naviplot, and I will delete the chart definition here and drag and drop it here. If you want to, I can send it to you. Yeah, let me try to fit all again. So now here it is. This is what we have at the moment. And then let's see what this chart definition is really all about. What I can do with it. I got 10 charts, as you can see, but I need in the bathymetric frame to specify a setting down here, chart definitions. And it's important that it is plan view mode. There are two modes. One is key plan mode and one is plan view mode. In the plan view mode, when you toggle from chart to chart, Navimodel will Naviplot will try to fit the current view to that particular chart. In plan view mode, key plan mode, the only thing that happens is that the current chart will be highlighted with an outline, a red outline or something like that. But let's try to see what happens if I, in this chart definition here, choose to right click, go to view. Zoom all, this is our chart. I can toggle chart number 2, 3, 4, 5, 6, and 7. These are the ones in scale 1 to 500. This is then 1 to 1000. And that's the other 1 to 1000. And then finally here is everything shown. There are so many possibilities, as you can imagine. With this, I can choose not to see the other charts, which may be a good idea. I can also, right now, I'm modifying properties. I mean, global properties, but when I go to the chart layout manager, when I modify an item here, then that item will only be modified in the current chart. This is quite nice because that means that you can actually specify items to be shown only on selected charts. So, but again, this is not a Naviplot project, of course. So, but we still want to make a key plan. So let me try to locate the key plan that we have here. In the key plan, I also want to add the chart definition file. this one here. So as you can see, it's visualized over there. We have two different geotiffs, and I think I can use the second one for the key plane. So, because I don't need the same resolution as you can imagine. Project, export. I thought I made another one. Or was that just for, I didn't make this one here. Okay, make another one that has a lower resolution. I can change the chart all here. I can change the cell size to 5 meters like this, and then I can right click boundary export geotiff all key plane. But apart from that, everything else is the same. Let's look at the export folder. This one here compared to that one there. So now Naviplot, right click. One for the key plane. There you go. And of course, here sequence is also important. Now the charts are drawn first. Zoom to. And there's, I mean, too much information here with all these numbers, but that really doesn't matter for now. Key plan, down here, chart definitions, key plan mode. If I go to chart number 1, then you can see that it's visualized here. Chart number 2, 3, 4, 5, 6, 7, 8, 9, and the overall chart. I will close. And then you can actually see that I can choose not to show any of the charts except for current chart. I can do that in a key plan as well. Like this, and then if I go to chart number 1, then I only see the current chart. That could sometimes be a good idea. And the same would of course apply here. It's only showing the current chart. So you can basically not see anything. Not even if I go to the overall chart. Yeah, we're almost there. There's only one thing I would like to do, and that is to create a GeoTIFF here based on the background map, like this. And then I'm not going to see anything. I just want to get rid of everything I have in the on the layout, and I'll create a new chart here. And it's not shown. I'm only showing this one here, and if I edit it, and change the size, something like this. So the key, of course, is that I should be able to see everything. I don't want to see it. And then I don't want to see the terrain either. You see the chart here has a cell size of 5. Try 2 meters and see how it works. Now, this is GeoTIFF from screenshot. And this is basically something else. Cell size, 16 megabytes. Yeah, I think that's going to be fine. I'll just say okay to that. How many charts? 16 charts. Yeah, that's fine. So it's creating this screenshot and putting the tiles together. It's actually similar to what we did with the side scan earlier today. And now save as. I want to save it in the project file here. Naviplot. Yeah, Navi model. Project export. And TIFF. Save. And then here, right click, add XY data bitmap, background, open. There you go. Now we can't see anything. Move it all the way to the top. And now here is the chart. And of course, we can include that here as well if you want to. Bitmap. Yeah, it's not so nice. I should have made a bigger one with a lower resolution, but for now that will have to do. Don't want to see that one. Like this. Okay. One final thing could be to print it out. I have installed a PDF writer on my computer, and you can also do it if you want to, but you probably haven't done that now. I can set up my printer, Qt PDF writer. Size should be ISO A1 portrait. my experience is that it's a good idea to go to one of the charts and then say File, Print, all charts from 1 to 10. See if it works. I can send you. I do realize that it was impossible for you guys to follow me here. I hope that it was possible for you to follow the export, but the actual Naviplot was, of course, difficult. I got the save dialog here, save as. Naviplot. Very difficult to find. Here it is. Virtual on-off PDF. And see if I can find it. Doesn't look too good. Something went wrong with my setting up of it. Let me try again. Yeah, print preview. It's not easy. Landscape. I also have to be honest and say that I'm not sure that this is actually ISO A0, so that could be the cause of it, but let's try to make it anyway. Print setup. This is a strange format, I think. Let's see how it looks now. As you can see, I haven't got everything, so I only have some of it. So it's basically a matter of finding the right size. This is not true A0. I'm sure you get the point of all of this. And here we have everything. Okay, guys, that is what I had for you. A little bit fast towards the end. I hope you can forgive me for that. At least you learned how to do contours and export geotiffs, and that was the primary purpose of this this exercise. So let me hear if you have any comments. I certainly have a comment. I would like to say that it is essential. The curriculum here for this training is huge. So I would really like to thank you for being patient, because there's been a lot of ground to cover. it was, the intention was that you guys should have done e-learning. I know some of you haven't actually done the e-learning, and that's a little bit, well, it's your own, basically your own problem, because I think it's a great advantage to do e-learning first and then do the course and then potentially complete the e-learning afterwards, because there's a aha experience when you see it again after the training, because you've seen it now, you've done it, many of the things you've done yourself, and it will certainly be a totally different thing to do the e-learning again. But I would still recommend that you do the e-learning. I mean, there's a weekend coming up, so you might as well. You've got all the time in the world, I suppose, unless your family objects to it. But it is my experience that it's enough. It's very good that you've done the training, but in order for this to actually be something that you can remember, something you can use afterwards, you need to, I don't know if the word maintain is a correct word, but you need to certainly not just stop now and then forget about it. And I'm not saying you should do it over the weekend, but if you go on a job in 2 months' time, you will have forgotten everything you learned now. That would be my recommendation. Don't just drop everything and start doing what you really like, what you really feel like, because then I wouldn't call this wasted, because of course something has stuck to your little gray cells. There's no doubt about that. But yeah, basically that was my lifting a finger here towards you. So, but still, I think it was great to be with you. I only wish that I could have talked to you more and could have seen you, but I think that's the way a virtual training course is conducted. It's not possible. My boss tells me that in the future we're only going to do virtual training, and I think there's a lot of advantages associated with virtual training, but there's also a lot of disadvantages. I've done a lot of classroom training over the years, and one of the things is I cannot see your reactions to what I'm doing. We don't have time for that, and I mean the whole arrangement here doesn't allow for it. So I don't know whether you've been able to follow me. I've seen your responses, and they indicate to me that you have been able to follow, and I'm really happy about that. Also, the exercises, the response I've had on your exercises gives me the same indication. So I hope that's what I wanted to say. I hope that at some stage I will meet you again, and then face to face. I know this is something that you can always say, but I really mean it. It's a different world, and I hope that we are soon going to be ready for it. I know that I have, in 12 days, I'm going to have my second vaccination. So then I'm free. I can go anywhere. I can do whatever I want to do, and I'm looking forward to that for sure. Okay, guys, that was it for me. I will stop the recording, and then I will send you the exercise of the day. And of course, I'm actually asked for you to send me your results, but no rush. I know this is Friday afternoon. You probably have some other arrangements, I could imagine. But if you want to send it to me today, then that's fine. And the reason why I would like to have your results is because I'm making statistics that will also give you something. The statistics will show where you agree. That could be the roll, mount angle, And where you disagree, that could be the heading and the pitch mount angle. Well, not disagree, but there could be a larger variation in the results. That's quite useful actually also for you to see that. And that's the only reason I'm not here to show that this guy couldn't do it or his results were wrong, because there are really no wrong results when we're doing training here. It's just a matter of seeing the variation, and it's quite normal to have something like that. So basically, guys, I will thank you for now. And I wish you the best of luck. I'm not superstitious, so I wish you the best of luck in your future work with our software. And to perhaps to the people from Cterra, I can tell you a small story about Edgar. I was on a job with Edgar Multibeam, and this was the first time Cterra was using Multibeam. And I told him, you have to have ZDA plus PPS. Ah, that sounds great, Edgar said. I said, how do we do that? How do we accomplish that? And I told him about the PPS. Pulse per second has to go in on pin number 9. Oh, no, we're not going to do that. 5 volts on a 9-pin input. That cannot be true. I've never heard about anything so stupid, he said. Well, you have to, everybody else is doing it, Edgar. You have to, no, that's not going to work, he said. So, but anyway, I told him that I think that, well, you've hired me as an expert, so you could maybe be a good idea to listen to my experiences. But anyway, 5 volts on a 9-pin port, he would know that's the most stupid thing he'd ever heard. So try to ask him if he remembered that. Well, at the end of the day, we did it, and he had to agree that it seemed to be working actually. So anyway, guys, bye now. I will stay in touch, give you the notes, and I'm still on Teams until 4 o'clock this afternoon.
Thank you very much, Lars. That was very interesting and instructive. Thanks.
That's good. That was certainly also the intention. I will upload the